All right, let's dive right into what is, for my money, one of the greatest detective stories of all time. We're talking about a cosmic mystery, a story about ancient ideas, a super meticulous detective, and finally a master theorist who just blew the case wide open. This is how we figured out the rules of the road for our entire universe. And this is the core of the mystery. I mean, think about it. Why this perfect, stable dance? What keeps everything from either crashing into the sun or just, zipping off into the void? It's a question that seems so basic, but it had the smartest people stumped for thousands of years. So, to really solve this mystery, we have to go back to the beginning. We've got to understand the first theory of the crime, an idea that held on for centuries, a picture of the cosmos that wasn't built on evidence, but on this beautiful idea of perfection. Yeah, for brilliant thinkers like Plato and Aristotle, the heavens were, well, heavenly. They were perfect, divine, flawless. So it just made sense that everything up there must move in perfect circles at perfect, constant speeds. It was elegant. It felt right. There was just one tiny problem. It was about to get completely wrecked by cold, hard data. Okay, so this is where our detective finally enters the scene. A guy named Johannes Kepler. And Kepler wasn't about philosophy. He was all about the evidence. He spent years painstakingly poring over decades of the most precise astronomical data available. He was looking for the first real clues. In this quote, it just nails Kepler's impact. He wasn't just, making a minor correction to the old theory. No, he was taking a sledgehammer to a worldview that had been rock solid for 2,000 years. This was a revolution. And boom, here's clue number one. The planets are not moving in perfect circles. Their paths are actually ellipses. You can think of them as kind of squashed circles. And get this, the sun isn't even in the center. It's off to the side at one of 2 points called foci. Right off the bat, the most basic rule of the old model is just gone. His second law found another huge crack in the old story. Now, it sounds a little complicated, but the upshot is actually super simple. Planets don't move at a steady speed. They literally speed up when they get closer to the sun and slow down as they get farther away. So much for that idea of perfect uniform motion. Now, his final clue was this really beautiful piece of math. It's a rule that perfectly connects how long a planet's year is to its average distance from the sun. It was an incredible discovery. But, and this is a huge but, Kepler knew what the rules were, but he had absolutely no idea why they worked. The detective had found the pattern, but he was still missing the motive. So, to find that motive, we need to look at the actual forces at play here. What is making the planets behave this way? Well, it turns out it's all down to a kind of cosmic tug-of-war. It really just comes down to these two big players. On one side of the rope, you've got inertia. That's the planet trying its best to just fly off in a straight line forever. And on the other side, you've got gravity. That's the sun constantly and relentlessly pulling that planet back in. And the result of this epic, unending tug-of-war is in orbit. The planet's forward momentum from inertia is what keeps it from just plunging into the sun. But the sun's gravity is always there, bending its path, preventing it from escaping. So a planet is basically in a constant state of falling around the sun, but never actually hitting it. So Kepler gave us the clues. We just figured out the motive, this tug-of-war. Now it's time for the master theorist, the guy who's going to step in and write the single, unbelievably elegant explanation that ties it all together. Isaac Newton. And this was Newton's legendary moment of genius. He looked at an apple falling from a tree, and he looked at the moon up in the sky, and he realized something profound. The force pulling that apple to the ground and the force holding the moon in orbit, they weren't two different things. They were the exact same force, gravity. The real game changer here was that word universal. Newton's law didn't just work for planets. It worked for apples, for you, for me, for everything with mass, everywhere in the universe. More mass means a stronger pull. More distance means a weaker pull. This one simple idea explained every single one of Kepler's clues. Let's zero in on that distance part for a second, because it's super important. Newton figured out that gravity follows what we call an inverse square law. All that really means is that gravity gets weak fast. So if you double your distance from something, the force of gravity doesn't just get cut in half. No, it drops all the way down to 1/4 of what it was. This exact mathematical relationship was the secret sauce that explained why orbits are elliptical. So there you have it. Case closed, right? Well, yes, but the story gets even better. Because what Newton did wasn't just explain the solar system, he gave us a tool to measure the universe in a way no one ever thought was possible. So Newton took Kepler's third law, that beautiful little pattern, and he added the final missing piece to the puzzle: mass. And suddenly, it wasn't just an interesting observation anymore. It was a working equation. An equation that meant if you could just measure how long it takes something to orbit, you could actually calculate how much it weighs. I mean, the power of this one formula is just mind-boggling. It became the cornerstone of astrophysics. Seriously, it's the fundamental way we have to weigh pretty much anything in space. We use it to weigh our sun, our Earth, Jupiter, and astronomers today are still using versions of it to weigh distant stars, to find and measure gigantic black holes, and even to prove that there's some mysterious, invisible, dark matter out there. And just to give you some perspective, using Newton's law, we figured out the sun has about 333,000 times more mass than our little planet Earth. That right there is why the sun's gravity is the undisputed king of our solar system. It's what holds the whole show together. The scale here is just cosmic. From the gentle, predictable curve of a planet's path to the wild, chaotic dance of two entire galaxies smashing into each other over millions of years, the exact same fundamental rules are at play. Newton didn't just solve the puzzle of the planets, he literally handed us the scales to weigh the entire universe. But, even with all of that incredible power, it's good to have a little scientific humility. This quote is a great reminder that physics gives us these amazing models to describe how things work, but what gravity actually is deep down? Yeah, that's still one of the biggest mysteries out there. And that brings us to one last really important question. For over 200 years, Newton's laws were it. They were the foundation of physics. They worked almost perfectly. But in science, that word almost is a really big deal. So were they the final word? Well, as it turns out, this detective story had one more shocking twist to come.